All right, so far in this chapter, we've talked about a variety of chemical reactions. We spent the first part of the chapter talking about redox reactions, and then more recently, we went over combination and decomposition reactions. So if you think about what's left over, we have two things that are left over. We've got this double replacement reaction and then a single replacement reaction. And that's what we're going to talk about in today's video. And let's start with the single replacement reaction. And single replacement is often just called substitution. And let's kind of walk through what makes a single replacement reaction a single replacement reaction. And I think it's best represented symbolically. So let's say we've got two reactants. I've got A plus BX. Really, what's going to happen is this X is going to get handed off, meaning it's no longer going to be paired with the B. Instead, it's going to get handed off to A. So we'd form AX plus B. So it's kind of like passing a baton from one molecule to another molecule. That's the best way of describing a single replacement reaction. So I'm just going to put a box around this, and let's take a look at an example of one of these reactions. And one of my favorite ones is with copper. You can take copper metal, meaning just copper wire from your house, and you can put it in a jar. And in that jar, just add some water and then add silver nitrate, which is AgNO3. And because this is dissolved in water, we're going to indicate that it's aqueous. That just means dissolved in water, right? The cool thing is when you combine this, you get a unique reaction. What you get is you get silver solid that forms. It kind of forms this gray, clumpy stuff on the inside. And then the solution turns blue because you're going to be forming copper nitrate, which is CuNO2, or sorry, CuNO3, 2. All right, and this is going to be blue, and it's going to be in solution. So this part is blue here. Over here, this is colorless. So let's take a look at what this looks like. I just think it's kind of a neat picture. And here's a picture of the silver forming, right? So if we look at it, this silver is kind of the gray clump right here. This blue solution, you can slowly see it develop over time, and it forms this kind of aquamarine blue. All right. The one thing we are missing from this isn't entirely balanced yet. If you notice over here, we've got only two nitrates, and over on the other side, we've only got one. So what I would do is I would put a 2 in front of this. That way I balance out my nitrates. Those are the polyatomic ions. But now we also have two silvers. So I would put silver right there as well. But kind of a neat reaction. It's one I like to bring into the classroom, but obviously because we can't be in the classroom, it's not something I can show you. All right, the other thing you might notice is that the single replacement reactions, meaning this reaction right here, is always under the redox category. So let's make a note here. And that is that single replacements are always redox reactions. Whoops. And so then the question is, well, why are they always redox reactions? And the reason this happens is that atoms are in their elemental state on one side, so for example, copper was in its elemental state on one side, but then went into a compound on the other side. That means that these always have to involve a redox reaction, right? Because if you're comparing something that's an element that always has an oxidation number of 0, versus when it's in a compound, it's treated as ionic. So this is a really simple tool to remember that a single replacement reaction is always a redox reaction. All right, so let's take a look at double replacements. That's our next one. And double replacement reactions, again, go by another common name. These are also known as metathesis reactions. And rather than it acting like a baton being handed off, I almost think of this like swing dancing. I don't know how many of you have ever swing danced or seen anybody swing dance, but imagine you've got two couples dancing, right? And then you just switch partners mid-dance. That's exactly what a double replacement reaction is. So let's say we've got couple AX and couple BY. They're going to do this swing dance, and A is now going to end up with Y, and B is going to end up with X. I know it's kind of silly, but I like the swing dancing analogy. You can come up with a different one if you want. Let's take a look at an example of this. And these examples are pretty common. This one's just going to be NaOH. That's sodium hydroxide, just household drain cleaner. And you can buy this aqueous, meaning it's already been dissolved in water. And if you were to mix this with hydrochloric acid, again, this is aqueous, meaning mixed with water, you can essentially just create salt water, NaCl. This is a neutralization reaction between an acid and a base. So acid-base neutralization reactions are a classic example of double replacement. Okay, so let's figure out what the remaining product would be, right? So over here, sodium ended up with the chlorine. So if we think about, well, what's left over, we're going to have this OH and H, which means we're going to have two hydrogens and an oxygen. So we can put this together and we can say, well, that means we're going to form liquid water. So this would be an example of a metathesis reaction. All right, the neat thing here is that these aren't redox reactions. And the reason for this is, you notice how they're all compounds, meaning the sodium is in a compound on both sides, the oxygen's in a compound on both sides, hydrogens, chlorines, they're all in compounds. And because we're not really switching anything around, these wouldn't be considered redox reactions. All right, so those are the two substitution reactions, or replacement reactions we're going to cover, excuse me. In reality, if you go into more advanced chemistry, specifically organic chemistry, there's tons of other reactions. I teach organic chemistry, so I get kind of nitpicky when I read this book and they're like, there's 6 main types of reactions. I'm like, there's a lot more than that. But if you decide to maybe switch gears and take some of the STEM classes, you can go on and learn about some of those really advanced but really cool organic chemistry reactions. All right, I hope that helps. Let me know if you have any questions.